Now we're going to look at the one that's probably the most involved here, and that's the rational inequalities. Now we're going to do these in a very similar way that we did to the polynomial inequalities by using that graph to help us solve it. But there's an additional complication here, is that we're going to have denominators, so we have to consider that. So the approach is going to work in much the same way, but with just slight differences. So again, we're going to move all the terms to the left-hand side of the inequality so that we're comparing to 0. Still the same idea. We're going to combine the terms and factor the numerator and denominator completely. Okay, so just like we were factoring the polynomial before, we're going to factor, but now we have a numerator and denominator. We're going to locate the zeros of each factor from the numerator and denominator and put them on a number line, breaking the line into intervals. So like before. Then we're going to find each interval and decide whether it's positive or negative. And then we're going to solve the inequality by choosing the correct intervals just like before. But we have to be concerned again, not only with the cases of the equals in the greater than or equals or less than or equals cases, but also we're going to have to worry about undefined cases because we have denominators now. So let's go to an example here. So here's what I mean. We have a rational inequality. So the rational expression 1 plus x over 1 minus x greater than or equal to 1. All right. So I'm going to bring everything to the left side. So 1 plus x over 1 minus x minus 1 greater than or equal to 0. Because again, we're trying to compare to 0. Now, what I have to do on the left-hand side is I have to get a common denominator. I have to put this into one fraction. So the only denominator we have is 1 minus x, so that's going to be our least common denominator. So I'm going to have 1 plus x over 1 minus x minus, no, 1, I'm going to have to multiply top and bottom by 1 minus x, so I'm just really going to get 1 minus x over 1 minus x. That's the same thing as 1, greater than or equal to 0. All right, put this over the common denominator there, and I would have 1 plus x minus 1 plus x. Remember, be careful, this has to be distributed to both terms in there. Greater than or equal to 0. So finally I get the 1 minus 1 is 0, and I get x plus x, so I get 2x over 1 minus x greater than or equal to 0. So that's my simplified inequality here, where I have it compared to 0 and I only have one fraction on the left hand side. So what I notice is, if I think about when the numerator and denominator are each 0, the numerator is going to be 0 when 2x is 0, or in other words, x is 0. And the denominator is going to be 0 when 1 minus x is 0, in other words, x is 1. So these are the numbers that are going to go on my number line graph that's going to help me solve this. All right, so 0 and 1. And I'm going to break there, just like before. Now notice, there is a little bit of difference between what's happening at 0 and what's happening at 1. So the x equals 0 is actually coming from when the numerator was 0. And the x equals 1 is coming from when the denominator is 0. So one thing that's true is I'm never going to want to take anything that makes the denominator 0 as part of my solution. So over here, just lightly, I'm going to think about kind of crossing out the 1. That's just telling me that when I go and pick my solutions in the end, no matter whether it's an or equals to or not, I'm never going to pick that as part of my solution. Okay, so I do need some points in each of these intervals. So I'm going to say -1 over there. I'm going to say 1/2 in there, and I'm going to say 2 there. So again, now I'm just going to go into the factored expression that I have over here, and I'm going to plug that test number in and see what I get as far as positive and negative. So I'm going to make my little a little example fraction here. So when I put in -1 to 2x, I get a negative number, right? So that's my numerator. On the bottom, if I put a -1 in, I'll actually get 1 minus -1 or 1 plus 1, and I would get a positive. So overall, I would get a negative for that region because I'm getting a negative over a positive, which is a negative number. All right, so now I'm going to try putting 1/2 in. So 2 times 1/2 is going to give me a positive number. 1 minus 1/2 is going to give me a positive number. And if I plug in, so that would be positive overall in that region. If I plug in 2, I'm going to get 2 times 2 is a positive number in the numerator. 1 minus 2 is a negative number in the denominator. So overall, a negative. So then I go back. What did I want? I wanted greater than or equal to 0. So that means I want positive or 0. So here is where it was positive. I'm going to take that region, and then I want to know when it was 0. So I'm going to take the 0 breakpoint because that's when the numerator was 0. I'm not going to take the 1 because that's what made a denominator 0, and that can't be part of my solution. All right, so I'm ready to give my solution. Inequality-wise, it would be 0 less than or equal to x less than 1 because I can have 0, but I don't want 1, and I want everything between 0 and 1. Interval-wise, that would be closed 0, open 1. And graph-wise, we'd be looking at, let's take -1, 0, 1, 2. So I'd be going closed at 0, open at 1, everything in between, or like that.